All right, so today we are going to be talking about parallel lines and transversals. Um, a lot of this is going to be review for you all, so I'm going to try to move pretty quickly. Through the vocabulary, we're going to move pretty quickly as well. If you need to pause to write examples in your notes, please feel free to do so. So let's get started. So 4 of our new vocabulary terms, there's a lot of them today, but the vocab is the bulk of the lesson. So the first one, parallel lines. I say this is a new term, it probably isn't to you. So parallel lines are those lines that go on forever and ever and do not touch. So kind of like this, except for imagine like a better drawing. So lines that go on forever and ever and never touch. How these are symbolized typically, you could have, like, let's just say this is line L, this is line M. You could see L parallel to M written like that with the 2 little lines in the middle. Another way you might see this, if it's just the picture, just like if we have a 90-degree angle, they put the little box in the corner. On lines like this, you'll see like a little, almost like a little arrow in the middle of the line, symbolizing that those 2 lines are in fact parallel to each other. What sets these apart from like 90-degree angles is on your test problems and your homework problems, the math people don't like to try to fool you with are they parallel or not. Typically, if they look parallel, they are parallel. They don't throw like those, oh, well, we don't really know if it's 90-degree problems in there. They don't do that with parallel lines, so that's good. Skew lines. Skew lines are a little bit more uncommon than parallel lines. So skew lines are kind of one of the big reasons why I have this rectangular prism in here. So skew lines are lines that are not coplanar and they never intersect. So parallel lines are lines that are coplanar and never touch. Skew lines are not coplanar, but they still never intersect. So an example of something like that would be, is if we took this line right here that I just colored in blue, and if that went on and on forever, it's going to keep going up and down like that forever and ever. And then if we took this line over here that I'm coloring green, that's going to go left to right but kind of offset, and that goes on and on forever. They're never going to intersect, but they're not on the same plane either. So we would call those skew. So skew is just when they're never going to touch and they're not in the same plane. Parallel planes are the same thing as parallel lines except for they're planes. So they are going to be planes that will never intersect. So they're going in the same direction, they'll never intersect. A good example of that would be like 2 opposite sides on, ooh, that one got out of hand pretty quickly. Would be like 2 opposite sides on this prism. So like this blue side is never going to touch the opposite side over here. They're just going to go on and on forever, side by side. Okay. And then hold on to transversal. We're going to use a picture on the other side for this. So a transversal is a line that cuts across 2 or more lines. So like on this page, if I labeled this line as A, this is B, and this line cutting across them is C, then C would be a transversal because it cuts across both lines A and B. So it's really just any line that cuts across 2 other lines. It intersects both of them. 2 or more. You could have a transversal that cuts across 50 lines. It doesn't really matter. So as long as there's 2 or more that it's intersecting, then we can call it a transversal. Because if it's not 2 or more that it's cutting across, then they're just intersecting lines. So now for the fun bulk of this lesson piece. So we're going to talk about different types of angles when you have 2 lines being cut by a transversal. So as we said before, I'm just going to keep line C labeled as our transversal, just for explanation purposes. Now, our interior angles are going to be any, so I guess I should say this first. So these two lines here that we have, okay, let's get some pen skills here. So we have these two lines, that was even worse than before, that are cut by the transversal. So those two yellow lines are getting cut by the transversal. So when we talk interior and exterior, we're talking relative to those two lines that are being cut. So interior, if we remember, interior means the inside. So like the interior of your house is going to be your kitchen, your living room, all the bedrooms, the bathrooms. And then the exterior would be like your yard. So for these purposes, our interior angles are all going to be found inside these lines. So in this green section here is our interior. And then our exterior is going to be this yellow piece that's outside the two lines. So interior is inside the two lines, exterior is on the outside. So angles 2, 6, or 2, 3, 6, and 7 would all be interior angles in this example. And then 1, 4, 5, and 8 would all be exterior. Okay, now let me just erase these so we have a little bit of a fresh start. So consecutive interior angles are going to be interior angles, so inside these lines, so they're going to be the green ones here, and then they're going to fall on the same side of the transversal. So an example of consecutive interior angles would be like angle 2 and angle 3. So they have to be on the same side of the transversal, so both of these are above that transversal C, and they're both on the inside as well. Let's just do this real quick. So inside is this piece, outside is this piece, just so we have kind of a rough estimation. And then, so our next type, so consecutive interior would be anything that is on the inside and on the same side of the transversal. So we could also say 6 and 7 are also consecutive interior angles. I'm just going to leave one example up there, though, just for sake of sanity. So our next type would be alternate interior angles. So alternate interior angles would mean they're all on the inside. So like 6 is on the inside, so that's going to be one of our angles. And then alternate means one on each side of the transversal. So alternate interior angles would have to be like 6 and 3. So we couldn't do 6 and 2 because they're both based on the same line. So we would want to do like 6 and 3 or 2 and 7. Let's choose this. It's too similar. We'll go with purple. Alternate exterior angles are much like alternate interior angles. They have to be on opposite sides of the transversals and one on each set of angles, or one set of intersections. So like 1 and 8 would be alternate exterior angles. So would 5 and 4. It's just dealer's choice on whichever ones you want to choose. What's a color we haven't used yet? Let's go with something distinctive like this. This blue is pretty distinctive. So corresponding angles are on the same side of, so they pretty much hold the same position. So like if I cut, let's just pretend I could cut this whole chunk out here, pick it up, and place it right over here. You see how those are identical? They're completely the same angles, same everything. So 5 and 7 share the same relative position in that. So 5 and 7 would be examples of corresponding angles. So 5, 7, 6, 8 would also be corresponding, 2, 4 would be corresponding, and 1, 3 would be corresponding, because they hold the same relative position. So above the below the transversal and on the left side for 5 and 7. So they're kind of like in that bottom left-hand quadrant. Let's see if there's anything else. So if we're intersecting, if we have two parallel lines that are being cut by a transversal, like we do here, if I wanted, I could draw this in and say, yep, these are parallel. If that were the case, then we could say that, let me star them with green. We could say all of our corresponding angles are the same, our alternate exterior angles are the same, our alternate interior angles are the same, our consecutive interior would not be the same. So all three of those would be congruent to each other. And what I mean by that is like these pairs that we set up. So like alternate interior, angle 6 and angle 3 are going to be congruent. They're going to have the same angle measure. And 2 and 7 would also, because they're also alternate interior angles. That doesn't mean all four have the same, but just each individual pair of alternate interior angles has the same angle measurement. Same with alternate exterior angles. So 1 and 8 have the same angle measurement, just like 5 and 4 do. But not all four of them are the same. It's just those individual pairs. Same with corresponding angles. 5 and 7 would be the same. 1 and 3 would be the same. 2 and 4 would be the same. And 6 and 8 would be the same. So there's some problem solving ways that we'll go through, not in this lesson, but later on, where pretty much if you have parallel lines that are cut by a transversal, you can figure out every single angle on that using these three theorems or postulates, whatever you want to call them, or definitions, I guess. But anyway, we're going to get into a few examples now. So I would make sure it would be really good to have this picture as an example with kind of your individual pieces in there as well, just so you have examples of every single type of these angles to refer back to. So parallel lines, skew lines, parallel lines, we already covered, or parallel planes, we've already covered those, so I'm going to skip over that. So in this example, they ask us to name all segments that are parallel to line BC. So line BC is this line running right up here. So the ones that are parallel to it, that are never going to intersect but share the same plane, would be GF, AD, and then the other one would be EH. Now EH doesn't look like it's in the same plane, but if we wanted to draw an additional plane in here, if I used this black marker, we could draw a plane just like that, and we can see where that plane would form in. Just because it's not specifically named in the picture doesn't mean it couldn't exist. So all three of those sets would be parallel lines. So line AD, line FG, and line EH. All right. Moving on, name a segment, skew to EH. So we have line EH here. So our skew lines are those that are not in the same plane and that are never going to intersect line EH. So line EH is going straight up and down. So we need the lines that are going like left and right, but aren't in the same plane. So like DC would work since it's on the front here. Line AB would work since it's on the front here. Oh no, what did I click? Line GB would work, and line CF would work. So line CD, line AB, line CF, and line, how is that the line symbol? Come on. So those are the only ones that work. And now a lot of people would say, well, what about line GH? Ideally in red, since that's what I was trying to use. Why wouldn't that be one? Because it's running left and right as well. The problem with using that one is that it intersects line EH, and if they intersect, then it's not skew. They have to never intersect, and they cannot be on the same plane. So that one would not work. But that's the most common mistake we'll see on those. So just be wary. Remember that they can never intersect and they can't be in the same plane. Name a plane parallel to plane ABG. So plane ABG, ABG. So it would be kind of like this. Now, the tricky thing is whenever they give us planes, they always use 3 points. But it's important to remember that that plane goes on and on and on forever. So even though we're only given 3 points, we can actually say that this is that plane they're talking about, this whole parallelogram here as the base, just because that triangle would go on and on and on forever in all directions. So you could really use any shape to describe that. And personally, I don't know why, but the parallelogram shape just works better in my head than triangles. So, looking for parallel planes, to me, I only see one example that's parallel, being that it'll never intersect, and that would be CDEF. So this top piece right here, because it is never going to intersect that plane ABGH. All these other ones kind of intersect into it at some point. So I would say plane EFCD. And you could just say plane EFC or DFC. It doesn't matter which specific one you choose. So we covered interior angles, exterior angles, consecutive interior angles, alternate interior angles, alternate exterior angles, and corresponding angles already. This is an additional picture, an additional example. If you want to put these in your notes, if you feel confident after the original one, don't waste your time with it. Okay, moving on. So classify the relationship between angle 2 and angle 6. So angle 2 and angle 6. So right away, I see line C as my transversal that's cutting through these two other lines. And I see 2 and 6 are on the same side of the transversal, and they're in the same relative position in that bottom right-hand side. So I can say right away that these are corresponding. 1 and 7, so I see these are on opposite sides of the transversal, so I know it's got to be alternate something. And since these are on the outside of these parallel lines, so we have the inside and then we have the outside, then I would say these are alternate exterior. Angle 3 and angle 5. Once again, these are on opposite sides of that transversal. Angle 3 is above it, angle 5 is below it. And they both lie on the interior, so I would say these are alternate interior angles. Classify the relationship between angle 4 and angle 5. So let's circle these, angle 4, angle 5. Now they have 3 individual lines that are being cut by this transversal P. Now if we wanted, we could just kind of black this section out over here because it's not relative to this problem. It's just additional information that can mess us up here. So angle 4 and angle 5, they're both on the same side of the transversal, but they're not in the same relative position. So since they're both in the interior, I would say this is consecutive interior. Angle 7 and 9. So this time, our one that's not really being used is over here on the right side, so I would just cut that out once again because it's just additional information that can mess us up. So angle 7 and angle 9, I can see that they lie on the same side of the transversal again. However, these are both in the lower left-hand corner, so I would say that these are corresponding since they share the same relative position to each other. They're both in that lower left-hand corner. So angles 4 and angle 7, I see they are on opposite sides of the transversal, and they're both on the exterior, because once again we have our interior in here and our exterior out here. So I would say these are alternate exterior angles. Classify the relationship between angle 2 and angle 11. Angle 11. Okay, so this one's a little bit trickier because on this one, the middle line is the one that we can cut out. But once again, I'm just going to black that out because it's information we do not need, which leaves us with all this bit is the interior, and this bit out here is the exterior. So both of these are in the interior, and they're each on separate sides of the transversal. So I would say that they are alternate exterior angles. Or, I'm sorry, alternate interior. Got mixed up myself. All right,